Good morning, Professor. I hope you're having a nice day today. Today I will be solving out problem 142, or problem 142 from chapter 4. To start off, I drew on top of the drawing provided for this problem to kind of visualize where my force A and B would be. Force A is drawn here because it's in the center of the beam, and force B is here, drawn about a third of the triangle area here. I then visualized the height of the triangle and of the rectangle over here, and drew out the 3 meters up here, and using the 1/3 meters here to basically find out that it's, 1/3 of the way here to find that it's 1 meter there in this distance, which then allows me to see that from point A all the way to force B has a length of 5 meters. And once I have all this drawn out, I use this information to find my force A and force B. So I first use the 2 kilonewtons per meter times the distance, which is 6 for the entire beam. This cancels out the meters and leaves me with the 12 kilonewtons. And then for force B, it's also 2 kilonewtons, seen here, per meter times 3 meters, since we are dealing with the triangular area, which has distance here of 3 meters. And then I divided it by 2 because we aren't looking for the entire rectangular area of the situation. We're just looking at the triangular half of it. So I divided it by 2, and that gave me 3 kilonewtons. So once I have my 2 forces, I add them together here to get my resultant force. Then once I have my resultant force, I am asked to specify its location on the beam of the resultant force, measured from the pin A, which is right here. So to do this, I found that there's a couple ways to solve this, and I decided to approach it using the moment equation at point A, which is the resultant force times the distance, and I'm solving for distance. So in order to find the moment at point A, I determined at point A in what direction my force A and force B are turning into. And I found that at point A, it's both clockwise, as you can see here. So we have positive clockwise. And again, force times distance, force, distance, force, distance. I add them together to get my moment of 51 kilonewton meter. And I use this, substituting into my distance equation to find that it is 3.4 meters with the location on the beam from point A.